oblige. But we're hoping to get a really interactive Q&A session. So we're going to hold questions, and then I'll put my moderator hat on, and I'll do my moderator duties. But let's go ahead and bring Scott up. Scott, it's all yours.
They put me last because they know I talk the fastest and everyone wants to get to the bar. So we'll try and go a little quicker. So tackling film contamination in MRFs, we all know that it could be a scourge and a waste of time and safety issues in cutting it out and things like that. And AMP is trying to come up with and have developed a product to help do that. But AMP's initial vision when Matanya Horowitz started the company was to enable a world without waste. So all of his technology, all of the things that he's designing are trying to improve the capture of high-value material out of a MRF so that it can then be repurposed somehow. So that's AMP's mission. Today, at a glance, we have just over 300 robots out globally. We're in over 80 MRFs and perfs. We're in Europe, Japan, Australia, and of course North America. So we're continuing to grow and we're continuing to iterate our products. What we're going to talk about today is film, right? It's the fastest growing segment in packaging. You see it everywhere. It gums up everything in the MRF and is not fun to deal with. How often in your MRFs is it every 15-minute shift? Every screen, they're cutting it out. And safety issues of being in there. You got to lock out, tag out. You've got to do all those things that you have to worry about just to get that out. Pre-sort, same thing. It's an issue. We're not the only ones who have technology either to deal with this film. There are ballistic separators and anti-roll screens, right? The industry's trying to come up with the technology to be able to say, hey, let's get the film either through the MRF without gumming everything up or get it out early enough so that all the other equipment can work effectively and process properly. AMP's technology, we call it the Vortex, and it's fully built by AMP. It uses no third-party technology, and I'll show a video here in a minute, but those tubes are pneumatic, and it uses the same AI that our robots use today. And it will spot the film, and then it will come down and pick it up and blow it to an expansion chamber, another belt for pre-sorting or for additional sorting, or a baler if you're able to sell it. But we're really confident that we can do that. The AI that we're using and the placements of these units that we're looking at are last chance fiber lines to get the film out, just past the OCC deck to get the film out before you get to the rest of the equipment. One of the things that it does, if it sees film and it sees fiber or another high value commodity, it's going to determine if it was going to grab the higher value commodity, it's not going to take the film. And it's done by both mass and we're putting in the rates to calculate, hey, don't take the milk jug for this little piece of film. Don't take the aluminum can for this piece of film or the high grade office paper. So we're really training the AI to be as specific as it possibly can. Doesn't mean we don't get contamination in the film, but by getting it out as early in the process of the MRF as we can, it's going to make the rest of your disc screens, the rest of your opticals, robots, and other technology work more efficiently so you get a higher capture rate. One of our goals, we're not there yet, is to be able to make a sellable MRF film with it too. Right, today it's still contaminated, but it can go on angled belts. It uses a blower system, Venturi blowers, and it'll blow it to wherever you want. Like I said, it could be a bunker, it could be a horizontal baler, it could be a sausage baler, or just a bunker, or right, so it can go anywhere. And that list of items there in the circle, that's all the different types of products that our AI identifies today. So this is just focused on film. Okay, this is going to be a quick video of the operation. This is in our lab, it's not in a commercial setting. That system is capable of working on up to 400 foot per minute belts. So you could use accelerators to get your burden depth down, things like that, to make the film more visible. And right now we've got one size that is 48 to 72 inch belts. That's the first go around version 1. The installs, we will have smaller versions. But the benefits that we see people, actually that are telling me they're gonna see, is cleaner products because the film's out early. Right, initially when Matanya came up with this idea, he wanted it on the fiber lines to pick film, right? So that the people at the end of the bale wouldn't have to dress the bales and take the film off. The issue is, if you're getting a bale rejected, a fiber, it's not the plastic film, right? It's not gonna be your respect for a contaminant. I mean, it's there. It's gonna be metals, other plastics, those types of things. So it's really not a high-end ROI in that situation. So again, these are just photos of the areas that we're talking about, all the different things that you have to do to deal with it. And like I said, you know, climbing in these screens is unsafe. People get injured with knives. It slows down your process. It just, you know, continues to create problems for the MRF. The other thing that we have, you can provide the data from our Clarity data system. Clarity is our version of a dashboard. Our AI system will actually do a complete belt composition report for everything on the belt. So it's telling you what it's targeting and what it's not targeting. And with Pick Success, which is a tool we're adding very quickly, we'll know exactly how much was pulled from each system. And one of the things I didn't talk about, the system could do up to the baseline, the new system, right? We're starting at 120 picks a minute. That's 30 picks a minute per tube, right? So that's full belt coverage. If you have that much film on that belt, you probably have a problem in the first place, but it can certainly do that. Where's that? Oh. The slide that you gave me is not in there.
Maybe it's after that one.
Was supposed to be a slide of us again. So, told you I'd go quick because, you know, we want to get to questions and the cocktails.
In that order. All right. So we heard a lot about the why, you know, why are we doing this? And then, of course, we heard about the different types of technologies. So I'm going to see if I'll start us off with a couple of questions, and then I'm going to turn it over to the audience and see kind of your thoughts and see if we can get this dialogue going. But I guess the first question that comes to mind is, to me, is just around like economics. So if you have a facility that has, you know, a number of employees that are working there, you know, to Rusty's point, this isn't necessarily eliminating a job. Frankly, the way I look at it is basically the same thing that has happened in the automotive industry. If you bought a car in the last 5 years, more robots touch that car than people. And that's because it was a dangerous work environment, paint booths and all this other stuff. So now the robots are doing a lot of that type of work so that the employee is freed up to do something else in a more safe working environment. But just from an economics perspective, do you have it down to the point where you can calculate like a return on investment? If there's a MRF operator that's putting in some robotic sorting technology, is there like a good kind of rule of thumb to kind of look at from an economics perspective?
I mean, it's going to
Microphone.
I'm sorry. Yeah, it's going to be determined by the company that's buying the equipment, right? They all have different parameters on how they're going to get capital or do leases. I mean, ideally, they're going to say, I want the biggest return, fastest return I can possibly get. But the ways you look at the return is that if you're replacing labor, right, so you have the labor savings cost, right? If you're not replacing labor and you're putting in a robot or an optical or something where there's not already a person today, that savings is gone. So then it's about throughput and capture of the higher value commodities and that improvement in their sales of product. So, and/or newer equipment has less maintenance, those types of things. So as people continue to iterate and these things get better, the ROI should be there. I've personally sold robots where the ROIs were not strong on paper, but the reason why the people were buying the robots is because they just can't get labor, right? So it's not that this is going to be a home run in terms of I'm going to get a 24, 36-month payback, but I'm going to be able to staff my line and capture all this PET or aluminum or natural or those types of things. So the payback's all in the buyer and what the value is to them, and it's not always a balance sheet number.
Do you want to answer that?
Yeah, I mean, the dynamic is shifted really, because when we used to do payback analysis for robots, it was pretty much a one-to-one, right? Where can I replace this order? How many picks a minute can this robot do? How effective is it? Can I replace this order? And just as a general rule of thumb, if you were a single shift operation, frankly, it was difficult to calculate good, effective ROI on a robot. If you were two-shift operation, that's when the robot really started to shine, because now all of a sudden you're replacing two sorters instead of one. That has shifted a little bit. Now, and like he said, it's not just a linear equation of replacing this sorter. It's, can I even get anybody to show up to work? That's the nice thing about the robot. The robot's going to show up. Even if the thing, if you have to do maintenance on it or if it breaks or whatever, it's there. And I've had several customers tell me they just can't, they've had to not run their MRF 1 day a week or 2 days a month or whatever because they can't get sorters to show up. And at least if you've got that robot sitting there, you can run your plant.
Mm-hmm. Yeah, that's a good point. And have you done any risk analysis to determine if the robot reaches singularity and becomes self-aware and takes over? Is that a concern at all? Nobody's done that math? Okay, I'm just curious. Do we have a microphone going around, or should I use this one? There we go. So we have a microphone going around. We have a couple of questions. There's one up here that I see.
Hi, this question is for Rusty. You mentioned that you had vision systems throughout some of your facilities just collecting data, but you aren't taking any actions with that data. You're leaving it up to the MRF operator to adjust the machine. What is preventing you from utilizing that data and creating that automated adjustment process?
Well, primarily it's complicated. That's why. It's we do have an installation that's actually going on right now in the UK where we're doing some of that R&D work up front to be able to have that automatic adjustment. It's just we're going to be very slow to market with that kind of thing because it is very complicated, and without some kind of manual interface, if you're just relying completely on the equipment to do that, it's very risky. So I'm not saying that we're not headed in that direction. I'm not saying that we're not working on that in an R&D standpoint. We definitely are, but we're going to be our company just happens to be very conservative when it comes to getting those types of things in the marketplace, because too many other companies kind of oversell what their capabilities are, and then they are in effect pushing the R&D dollars onto their customer instead of taking control of that in-house first and then pushing it to market. So that would be our answer. Some of the other people in the room may differ in that business approach, but we just happen to be very cautious in how we go to market with those kind of things. And I definitely think that in the next 2 years, 3 years, 5 years, we're going to be seeing the marketplace head more in that direction. I know that's probably not a direct answer, but I'm a sales guy, not an R&D person, but I can just tell you that's what I'm hearing internally, is that it is complicated, and we don't want to rely totally on the equipment to do it yet. We like that manual intervention.
As a follow-up to that, do you think that's something that could be retrofitted to existing MRFs, or is that something that's a core technology, it's only available on new stuff?
No, 100% can be retrofitted, for sure.
Okay, cool. I think I saw one.
So to take off on what you were saying, David, about where some of this technology is going. Rosie the robot was pretty sarcastic, right? And then on top of that, there was an article, or I heard on the radio today about the new Bing chatbot and how it is, developing an affinity for some of the people that it's been working with, and also how it's like making threats against other people. First question is, if we were in hypothetically a local government looking to procure a long-term agreement for a MRF processor, one, how do we make sure that those robots don't come after us in the future? And two, really, quite seriously, in the future, if you were reviewing an RFP, what advice would you have for a local government to look for in the design and layout of a new MRF? If it's a brand new thing, what might we want to make sure that we think about as we're reviewing proposals?
Yeah, so that's a great question. I know for a fact you always want to future-proof, your MRF, to the greatest extent possible. But when you're looking at design, so that's a good question. When you're looking at design, are you thinking about, 5 years down the road, how the waste stream is changing, some of the policy directives? Are those all part of the early engineering and the feed study and those types of things?
Certainly. Rusty talked about vision systems throughout the MRF. We're doing that same thing, right? We have our platform that we call Clarity. It's a database, and every object that goes underneath our vision system, whether it's before robot, after an optical or another piece of machinery, is going to give you a count. And it's going to say, we saw X number of pieces of X, Y, and Z. We have mass in there now, so it's now convertible to a weight. And we're also putting in dashboards that are going to convert that data to finances. So when you put on your last chance line a vision system that says, or your residue line, hey, you're losing 10 PET bottles a minute, or you're losing 5 milk jugs a minute, right? We all know that stuff is good money, right? If you can capture that value, then you can use that information to make changes in your system beforehand, or you can get alerts from these vision systems. Hey, why am I getting so much aluminum here? Is my eddy current down? Is there a problem? That you can get an email to your phone, you can get a text to your phone, email to your computer or text to your phone. So the data can be real-time analytics to act in your MRF and make changes to the rest of the equipment, as well as future as you grow, right? If you start taking in different material from different routes, right? We just picked up this contract. How's this material affecting the operation of my equipment? Do I have to run it on a different day? Do I have to change the angles of my screens? Do I have to speed up the belt or slow down the belt? So all of that data can be gleaned from the data we're capturing in our vision systems today.
And maybe, David, to answer your question a little bit, understanding what AI is, I think, is a big first step, because a lot of people, because they've seen, 2001: A Space Odyssey, and they've seen Terminator, and they've seen iRobot, with Will Smith, they envision this machine that, because we're calling it AI, has this artificial intelligence that has the ability to sort of self-learn. That's a little bit of a misnomer. The machine does have an ability to learn. It does gather data. It does acquire data, but then that data goes and sits somewhere, right? The machine's not really doing anything with that data. I don't know how AMP does it, but I know that the way we handle it is we have taggers that then have to go take that data and sort of interpret it for the machine and then upload that data back to the machine. So it's definitely learning, and it definitely can evolve as time goes on, but it's not self-learning, if that makes any sense. So I don't think you have to worry about the machines taking over yet. We're not quite to that point. We still have to have that manual intervention where the tagger goes in and uploads that data, but does that help a little bit?
Yeah. Well, Hollywood has definitely done some exaggerations, because the reality is those of us that are in the robotic space, that as soon as you turn the robot on, it's probably just going to fall down that first time. It's not going to go and take over the world. But no, it's a great point. It's a great point. The other thing that I'll add, because a lot of our customers as a company, we work a lot with the military, And so they have landfill diversion goals like a lot of municipalities do and a lot of big corporates do as well. But they have us thinking beyond the technology, kind of like the human component. What else can we do outside of the technology, which is great. I'm a big fan of technology. But sometimes adding something like a makerspace to a MRF is a good example, or partnering with a Goodwill type of organization, or Salvation Army, something like that. A lot of what we do is building community partnerships, so we look outside of the installation, we bring in the county, we bring in the city, we bring in the school district, and then together we try and look at, how do we ultimately get to a place where it's zero waste? Because we all know that that's a great aspirational goal, but until you can knock down that waste stream to about 20%, it's really overwhelming. A lot of the people that I talk to that are operating landfills, they're just like, Dave, I got 3,000 tons coming in today, and guess what? I got 3,000 tons coming in tomorrow, so I'm just trying to stay on top of it. And it's true, that's the reality, and I understand that. But ultimately, when you start designing these systems, you definitely want to be thinking about the end game and kind of where the market's going. And I think the industry is changing. These robots are just getting better, frankly. I remember first conversation that we had, the picks per minute were in the, 40s or 50s, and now it's just phenomenal. So they're just getting a lot better. Any other questions? Yes, ma'am. Oh, we got our microphone up here. It's making the rounds. We got a question up here, and then we got another one back here.
Hello. Yeah, when you are talking about zero waste and about robots and the sorting system, even it doesn't matter how advanced machines we develop, first thing that whatever we need to recycle, it should go through proper channel. If I throw phone or a pen or a paper or plastic, I should know what is the destination for this product, finally where it will go. And if I know where it is going, then I should know how I should dispose it of so that it goes to the right destination. And when I make any use of these products, I should also think from where it came. If I'm using paper or misusing paper or abusing, I should know that it came from trees. It came from some forest. So this kind of knowledge or information is very important for everybody so that we can minimize. In the morning session, one of the participants asked that how we can relate these things emotionally. So my answer, maybe she's there, yeah. That was very touchy question. That many things, if we waste food, we think, oh, if we waste food, maybe somebody will be hungry. We should not waste food. Same way, any product or any material, if we waste, we should think how far it has to travel to come back, and from how far it traveled to come up to this level. So that kind of understanding and that kind of connectivity with nature and environment, I think that can help. Sorting systems are good, but before that, like you showed the pictures of Pacific Ocean, it is full of plastic and bottles, but how did those bottles reach there? I think one of us or all of us are responsible to make those plastic to go up to there. If we have disposed those bottles or plastic correctly, they may not have ended up in that ocean. Correct? Mm-hmm. And you showed the pictures of landfills also. Maybe from the beginning, from the home itself, when we dispose of the material, we are not doing correctly. We are not putting in the right bin, or the system is not doing correctly the collection. They are encouraging us put everything in a single stream, put everything in one bin. So first we are mixing everything, and then we are making the machines to separate them. It's like a self-inflicted wound which we are trying to, now treat it. So I think everything has some cause. How we reached up to this level of contamination and bad disposal of the garbage or trash. So we need to go to the route. Like you said, it's your dream to take off all the landfill. There should be no landfill. If we all live with that kind of dream, we should know that whatever we are throwing, it should go to the proper destination recycling facility nicely to minimize, so that we don't need this much, exercise and all those.
Yeah, it's a great point, and that's really the definition of the circular economy. So obviously right now we live under a take, make, waste, a linear model where we're just going to extract a resource, we're going to convert it into something, we're going to use it for probably a few minutes. In the case of this plastic bottle, will probably be in my life for about 11 minutes, and then I'm not going to think about it anymore. Well, I do, because I'm a garbage nerd. But yeah, that's right. When you have to really think about the end use, that life cycle for that material. I mean, right now, PLA, plant-based, plastics, bioplastics, all of those things, our goal, at least I'll say for myself, our goal as a company is basically to work ourselves out of a job, where we've worked with clients, we help them put them on a path to get to zero waste to landfill. Because ultimately, hopefully, the world that I see is we go into existing landfills and we mine those resources. One of the presentations earlier this morning was titled Buried Treasure. I don't know if you sat in on that one. But that whole concept of buried treasure, to me, I'm like, well then if that's the case, we should all be pirates. We should be mining those landfills, extracting those resources, bringing them back into the circular economy, and being, responsible for the generations that come after us. So that's kind of my philosophy. I don't know if anybody wants to add anything to that, or see if we have any more questions. Any more questions? I think I saw one in the back there.
Hey, Rusty. My own question was, on your slide comparing the 2013 and the 2022 MRFs, has the MRF footprint changed?
I'm sorry, is what?
The MRF footprint, the size.
Oh, the MRF footprint.
The footprint,
For
yeah.
certain, it has. People are, always wanting more tipping floor. They're always wanting more bale storage. And certainly as you increase the amount of automation that's going to go into a given MRF design, if you look at a MRF, it will say 25, 30 tons an hour in 2013 versus the same MRF today, there's considerably more equipment. You don't realize how much room an optical sorter takes up. Robots are pretty much kind of plug-in, right? So they don't take up a tremendous amount of space. They take up some, don't get me wrong, they take up more than a sorter, but it's a couple feet here and there, right? An optical sorter, every time you add one, you're typically adding about 30 feet to a given design, because you've got the speed belt, and then you've got the optical sorter, and then you've got the discharge conveyors to take the material away from it. So yes, for certain, footprint has increased, and so your building size has increased as well. Yeah, good question. Tim, did you?
Question over here.
Rusty, just a quick question regarding municipalities and processing fees. With the new investment of new MRFs, are you seeing third-party vendors bidding lower processing fees? I mean, obviously, we talked about the cost, everything else going up, and processing fees were up to like $144 a ton in some cases. With the new technology, less labor involved, are municipalities seeing, is there any data to support that?
I don't know if there's data to support that, no. But I do know that it's a very competitive marketplace. And if a municipality puts out a bid that's processing fee based, they probably are going to get a pretty wide range of results back, because each one of them is going to always have something a little bit different in that number. And I can't really speak to the pricing, because we're not processors, we're just the equipment vendor, but they're going to get a wide range, because building sizes may be different, equipment spec may be different, tonnages that equipment can process may be different, and developing a baseline for how to evaluate those proposals is going to be important, because they're going to come in all over the board. I don't know if that helped any.
So,
Plus, we're in an antitrust situation, and I want to make sure I'm not talking about pricing. But
so I'm gonna see if I tag on to that, and you both of you may have some perspective on this. So, let's say you have a municipality that's, thinking about putting out some kind of an RFP. Is there a particular structure that, as an equipment supplier, that you may think about in terms of having the best likely scenario that works best for the municipality and both for you? For an example, you don't build buildings, so does it make sense for the municipality to say, hey, we can go out and get a bond and build the building, and then you just come in as the equipment supplier? Or have you done any projects where it's almost like a DBOT, where you design, build, own, and then ultimately transfer it back to the municipality? Any thoughts on that?
we've seen them all over the board. It depends on the municipality and what they're trying to accomplish, but at least from where we sit, the recommendation that we typically give to the municipality is we don't build buildings. Building contractors don't build equipment. So if you buy the equipment from us and buy the building from the building contractor, you're going to get the best price, because the building contractor is going to mark up the equipment vendor is going to mark up the building. The argument there is, yeah, but project management, and I want sole source responsibility, and I only want to cut one check, and those kind of things. All good arguments, for sure. But at the end of the day, they're going to get the best price. And project management between, and we do these all the time, but project management between the equipment and the building is pretty flawless. As long as their project manager and the project manager for the equipment are communicating and make sure things don't slip through the crack, we can make that pretty painless for the municipality.
Okay. Any thoughts on that and that whole DBOT model? I don't know if that works for you.
I actually don't do any of our municipal work, so I have no idea how we price it or how we bid on it, and I'm kind of happy about that.
Okay, fair enough, fair enough. Any other questions?
So team asks a great question out there, and I don't feel 100% capable to answer that, but I have a comment to do about processing. Processing fee is that cost that it should cover everything that you pass by the line, correct? Yeah. We've been during the conference, we've been talking about, and I think that you, Rusty, mentioned some of that, right? Price of steel, price of the mechanics when they're going to do electrical or any labor included. My humble opinion, and super personal opinion, not by the company that I work, is that the processing fee should not be fixed in a contract for a long term, even if it's adjusted by CPI. And the reason for that is because you don't control the market. You don't control the labor. I think that it was you, Rusty, talking about signing bonus or with Amazon for $10,000. We got to always think about the cost for everything that is involved, and I may risk myself by saying that everything doubles. Only the wire that we use for the bales has increased more than 40%. So how do you fix or know what the proper processing fee should be in a municipal contract for the years? But I asked the mic just to make a comment about the amp for the robots out there. You mentioned a number that it caught my attention. You say 120 pickups per minute, right? That was the number.
Yes.
That will take 2 sorters. But there is a double-edged sword here that I would like to talk to you guys about, is if you have 2 sorters, when you're measuring him, he's probably doing 60 pickups per minute, and that will be a good standard. Only if that person, that sorter, is working his 6.5 or 7 hours continuously out there with the breaks, in the same pace all the minutes that he's working, and that is not happening. That's why I love technology, because those machines, those technologies are not going to get tired. But I close it with one question for you, Chase. Maintenance on the technology that you're offering, on the vacuum system, can you share with us what it should be the maintenance? Is that by day, by week, and how much it will be, and what kind of maintenance do you see on the equipment that you're putting in front of us today? Thank you.
Typically, maintenance cost for a robot, depending on the size and the number of robots, is going to be between 1.5% and 3% of the capital expense of the unit. And we're actually, I can't say, but we're coming out with some new products that are actually going to bring down that maintenance cost. Different filters to stop clogging, right? Anti-clogging mechanisms, newer cups that wear less, last longer, right? And provide better suction and successful picks. So as we continue to do that, the maintenance cost for our systems are going to come down. All of you have been in MRFs. They could be 100 degrees inside. They could be 20 degrees or less, depending on where we are in the country and the world, right? So, and they're dusty, they're dirty atmospheres. We project, or we request our customers to do, for the one that does 120 picks a minute is a 2-armed robot, by the way. So it's up to 60 picks per arm, right? So that robot should take 30, maybe 40 minutes of maintenance a day. And that will go down by 5 minutes once the new gripper systems and the new cups are actually commercially available. Right? We've designed them, we've tested them, they're in commercial MRFs today. Now it's just a matter of supply chain and getting the best deal and making the orders for those types of things. So, yeah, I mean, there is maintenance, just like everything else, but it can be done, if it's done continually on the schedule and right on our CPU, the main system, and our Clarity database, you can go in there and see what's due, and when it's completed, you can check that it's been done. And then it will count down to the next time you need to do that task. So it's not even like someone just has to have memorize it or have a book. It's in the computer. So. Pardon me?
He was asking specifically about the vortex.
Oh, you were asking specifically about Vortex. Sorry.
The film.
Sorry, that was my bad. That went straight over my head. So the maintenance on the Vortex, we're still coming up with the parts and what's going to wear. It's in our beta pre-release phase. We've got 4 units out in actual operating MRFs today in North America. We've got 1 in one of our secondary sort facilities operating. So we're literally just testing, running different scenarios to see what the wear is. I mean, we anticipate, because I had to give it to a customer who's getting ready to sign a contract, that is going to be roughly $7,500 to $10,000 a year in maintenance cost. There's not, it's not a lot of wear parts, just the tubes going up and down, right? Everything else, it's the Venturi system that's creating the suction. You need a little bit of air from your compressor, because it didn't show it in that video, but it's an anti-clogging mechanism. So all the tops of the tubes, if one gets clogged, the air will close the other ones to create enough suction to declog itself. So we're not 100% positive what your maintenance cost is going to be on that, because they haven't been out in the market long enough. But right now we're anticipating $7,500 to $10,000 a year.
Cool. So Ms. Kuhn with EPA talked this morning about grants and different things like that at the federal level. Rusty, are you seeing any of that, or state grants or any other grants that might help to cover the cost of some of this automation?
Yeah, definitely. I mean, I think a lot of people out here probably know the Recycling Partnership has grants available. I saw some of those guys here today, but anyway, they've got some grants available for PET. And it's not just for automation, it's anything related to improved PET recovery. So it could be an optic, it could be a robot, it could just be a bunker and a conveyor, but anything that's going to improve PET recovery, they're willing to look at those grants. Some of them are matching grants, just so you're aware going in. They're not just straight out write you a check grant. Some of them are. Some of them will give you, I think it's even up to about $500,000, depending on what your project is and what you're doing. Some of them are matching related, and then of course the EPA has announced these new infrastructure grants that are coming out. I think it's about $275 million they're going to be investing here in those. So those are starting to hit the street, and we're having customers call us more and more about applications for those. So yeah, there's plenty of money available for automation for sure.
Awesome.
Well, to piggyback off that, the TRP still has their polypropylene grants. Instead of them doing them quarterly right now, they're on a rolling basis. So if you've got a MRF and you want to do a polypropylene capture process program, you can write a grant request, turn it in, and they can turn around the request in less than 6 weeks, depending on the size of the project. And they're also working on MRF film grants, but their end goal, and this is directly from Spence and Rob Taylor, their end goal is plastic to plastic, right? They don't want plastic to pyrolysis, they don't want it to decking. So they're trying to come up with solutions to capture clean film and have it be reused into its original product. So those grants are going to take some time. And then, of course, one you didn't mention is the Carton Council. And again, all of these are going to be matching. They want you to have some skin in the game. You know, if your project's $500,000 and you ask for 500, they may give you 200 or 250, right? They don't want to give you the whole project money because they want to see that you're invested in the process yourself. But I highly recommend applying. They've got customers that have won TRP. We've got customers that have won TRP and bought units. So it's hugely helpful.
Cool. Any other questions before we go into double jeopardy? No? Any other questions? I mean, you could wrap up early. That's not terrible. Okay, I'll tell you what. Both MachineX and AMP Robotics have booths in the exhibit hall. So we're going to mosey over there in a little bit. This way? This way. Thank you. I have a booth at the bar, so you can come on over and hang out with me if you'd like. But other than that, I'd like for you to thank my panel, my speaker here on this panel. And I think I'm going to officially adjourn us. So thanks for coming.